Welcome to our channel, Dr. Bala's Chemistry. I'm your Dr. Bala. So here today we are going to discuss about the previous year, that is last 10 year CBSE board chemistry questions, in which part 36. We are going to discuss the part 36, in which we are going to discuss about the amines. Okay, so from today onwards we are going to start the amine chapter, in which the first thing is, let us start with the IUPAC nomenclature. What is that IUPAC nomenclature? So here they are given a structure. What kind of structure is given? One aniline is given in that. So if you regarding there is a functional group 1, second position, third and fourth. Here it is fifth. Here it is sixth. Are you able to understand now? So here 2, 4, 6. That is 2, 4, 6. Tribromo aniline. That is the IUPAC name of that structure given. One, that is 2, 4, 6 tribromo aniline. That is the structure given. And second, you just look at, this was asked in the year of 2010. You just look out what are the things. So here functional group is 1, 2 and 3. Here it is 4. That is the third position I have 1 ene, and first position I have 1 amine groups. And here total number of carbon atom is 4. That is what I had written as bute. Third position I have ene, bute 3 ene, 1 amine. Are you able to understand? So in first position I have amine. Okay, so bute 3 ene 1 amine. That is the IUPAC name of this one. And this question was asked in the year of 2012. You just look out the same thing. So here we have to find out the functional group, and here functional group is there and long chain is there. So here number 1, 2 and 3, here also 4. According to the same rule, as we know that functional groups are attached in the second position. So total number of carbon atoms 4. That is the same thing. That is the bute 3 ene 2 amine. Okay, are you able to understand, students? In second position we have amine group is there. That is what bute 3 ene 2 amine is there. And next one is write the structure. They given the name, but we have to write the structure. So N-methyl ethanamine. So here N-methyl ethanamine, that is a N. Methyl group is there, CH3 is there, and ethanamine, C2H5. That I have to write N-methyl ethanamine. This is the right structure of N-methyl ethanamine. And next one is, you just look at, it is very important one, CH3CON. So as we know that what is the functional group of amide? So when we look at the C double bond O NH2 is nothing but amide. Am I right? So it is a amide. Okay, organic amide. If it is CH3 group is there, ethanamide. Okay, so the CH3CONH2, instead of one hydrogen, one phenyl group is there. That is what N-phenyl. Just look at N-phenyl ethanamide. N-phenyl ethanamide. Are you able to understand, student? So how to write the structure? So write CH3CONH2 is a ethanamide. Okay. So 2 carbon atom containing amide, that is what is called as ethanamide. Once if I got ethanamide in first position phenyl group, that is N-phenyl ethanamide. That is the right name of this compound. Are you able to understand? And next one is, write the chemical equation of Hofmann bromide degradation. This question was asked in the year of 2008, 2012 and 2016 also. So what is the Hofmann bromide degradation? Suppose, so here R, C, double bond O, NH2 is there. Okay, C double bond O, NH2 is there. That I am going to react with sodium hydroxide, NaOH, along with bromine. Okay, that time I will be getting converted the product like this, R NH2 or NH2. Amine, the conversion of amide into amine, that time I have to use the Hofmann bromide degradation reaction. Amine is getting converted. Along with that, I will be getting sodium carbonate, CO3, sodium carbonate, along with sodium bromide, along with some amount of water. These are all the byproducts of this one. Suppose if I am taking 4 anyway, this is a balanced equation. You just go on balance it. So you will be getting idea. So here the thing is C double bond O NH2. Here we are just removing this C double bond O group. Okay. So usually this equation, this Hofmann bromide degradation is used for the carbon number. Reactant we have how many carbon atoms? If suppose if you consider this R is CH3, that time CH3CONH2. Here one CO is there, one carbon less. If I want to get one carbon less product, one carbon less, that time I have to use this Hofmann bromide degradation. By the way, I can remove one carbon atom removed product. Okay, are you able to understand? This is a very important one. Amide can be converted into amines. And next one is a very important synthesis. That is a ethan nitrile to ethanamine. So what's the difference between this ethan nitrile and ethanamine? This is what we have to understand the concept behind it. Ethan nitrile. How many carbon atoms do you think? So do you think how many this carbon atom having? So it has 2 carbon atoms. That is CH3CN. That is what ethan nitrile. So what is the ethanamine? The ethanamine is nothing but how many carbon atoms? CH3, CH2 and here NH2. This is what it is, ethanamine. Okay, so ethan nitrile containing 2 carbon atom. Here also 2 carbon atom. But the thing is ethanamine. So ethanamine, how many carbon atoms? 2 carbon atoms. So how we can use? So here one CH3 is there, along with that CN group is there. So we have to include this carbon also for naming ethan nitrile. So ethan in the sense, so you should not write CH3, CH2, CN. That is not ethan nitrile, that is propanitrile. So here ethan nitrile in the sense totally 2 carbon atom with inclusive of the CN group. Okay, the CN carbon also you have to include in this. That is what ethan nitrile. So just by the reducing agent, just if I am using nickel hydrogen, it will be getting reduced as this product. And the next thing is nitrobenzene to aniline. This was asked in the year of 2014. So what is the nitrobenzene? So here I am having nitrobenzene. What is the structure of nitrobenzene? Here it is NO2 is there. And that I have to convert as aniline. Aniline in the sense, what is that aniline? So it is nothing but it is NH2. What is that? NH2. NH2 that I will get. How many, if there is any change in that? So there is no change in this. Common, you have to think about the benzenic is common here. So NO2 can be converted into NH2. So we have to use perfect reducing agent. If I use a reducing agent like a nickel as well as a hydrogen, that time I will be getting reduced to amine. Okay, I am getting amine as a product here. Aniline as a product from nitrobenzene. And next one is a very important one. You just look at CH3, CH2, Cl. So in reactant side I have 2 carbon atoms. In product side I have 3 carbon atoms. If I need to add 1 carbon atom plus 1 carbon, that time I have to add Cn. Just keep it in mind. So whenever I need to add 1 more carbon atom, that time if there is any possibility to add Cn, that time we can add. So here I need to get Cn, CH2, NH2 is there. That is what the CH3, CH2, Cl is there. Along with that, if I used react with KCN, I will be getting CH3, CH2, Cn. CH3, CH2, Cn I got. If I reduced with, what is that? I reduced with nickel or hydrogen, I will be getting the product. What is that? How many carbon atoms? CH3, CH2, CH2, NH2. Okay, that C triple bond N, the C triple bond N is there. That can be, suppose if I add one hydrogen, nickel hydrogen HH, that time this bond is getting break. Here I got substituted one hydrogen. And if this bond is getting break, I will be substituted with hydrogen here. Instead of that bond, I will be adding hydrogen. So here CH to NH2 is getting converted. Are you able to understand, students? This is very much easier and very much important also. And next one is alkyl halide to quaternary ammonium salt. What kind of quaternary ammonium salt? Alkyl halide. Suppose if I am taking CH3Cl, am I right? CH3Cl. This is a alkyl halide. If I am reacting with, what is that? Ammonia. NH2 I will be written. So here I will be written as HNH2. So if it is removed as like this, so I will be getting CH3NH2. Okay. And along with that, if I use excess amount of CH3NH2 is there, and alkyl halide. What kind of alkyl halide? I will be getting CH3NH2. Am I right? So here I have to add alkyl halide. That is CH3 Cl. At the time what happened? This Cl as well as this hydrogen will goes off. So that CH3NH. So here CH3 that I got as a product. And after that, if I add one more CH3Cl, what happened? This hydrogen will move and the Cl will move. What happened? So here I will be getting CH3, here it is N, here it is CH3, here it is CH3. Okay. And suppose if I add excess amount of CH3Cl, that time what I will be getting? So here I will be getting CH3. Okay. CH3. So here what happened? CH3 3 times N plus Cl minus. That I'll got as quaternary ammonium salt. That I'll get as a quaternary ammonium salt. Are you able to understand, students? This is very much easier. Here I got 1 degree amine. Here I got 2 degree amine. Here I got 3 degree amine. After that, if it is react with CH3Cl, I'll got quaternary ammonium salt. So I'll be getting quaternary ammonium salt. CH3 4 times N plus Cl minus. Are you able to understand? This is very, very important one. And next one is 1 degree amines have high boiling point than 3 degree amine. This question was frequently asked in the year of 2008, 16, 14. Many number of years they asked the question. First of all, whenever we have to solve this question, we have to write the structure. 1 degree amine. Suppose if I am taking RNH2. This is a 1 degree amine. What about 3 degree amine? Suppose if I am taking R3N. That is what? 3 degree amine. So here hydrogen bond is there, which will be reacting with the hydrogen bonding is there, but in the case of a 1 degree amine, here there is no hydrogen in nitrogen. That is what there is no hydrogen bonding, no H bond. Here in 3 degree amine. This is what it is 3 degree amine. This is what it is 1 degree amine. 1 degree amine, I have 2 number of hydrogen along with the nitrogen. That's what it can involve in hydrogen bonding, so that the bonding will be very strong. That is what it has high boiling point. But here the hydrogen bonding will not be existing, so that it will be very weak, so we can easily remove it. That's what the boiling point is very less for 3 degree amine. And next one is arrange the increasing order of boiling point. This is also very, very important. You just look out. So here alcohol is given, 1 degree amine is given, and 3 degree amine is given. Here I have 3 degree amine. Here I have 1 degree amine. Here I have 1 degree alcohol. So as you know that alcohols will be having the position number 1. Why it is position number 1? And here also it is the position number 3. 2. This is position number 3. Why? Why I am getting alcohol as a position number 1? Because this forming hydrogen bonding. Hydrogen bond, that is what will be very strong. Here also it forms a hydrogen bond because it's a 1 degree amine, am I right? This is also form hydrogen bond. But the thing is, when compared to alcohol, the amines having lesser boiling point. Why? This is because of that. Here hydrogen is attached with oxygen. Here hydrogen is attached with nitrogen. The oxygen is highly electronegative when compared to nitrogen. That is what this plays a first place, the highest boiling point in this given compound. And here hydrogen bond existing, here there is no hydrogen bond is existing. There is no hydrogen bonding here. That's what this will be at least one. Are you able to understand, student? This will be very much easier. Just you look out here, both are having hydrogen bonding, but the thing is here hydrogen is attached with the highly electronegative atom when compared to nitrogen. Okay, here oxygen is there, here nitrogen is there. Oxygen is highly electronegative, so that which will be having high strong hydrogen bonding. That is what it has higher boiling point and when compared to this one. And this is a 1 degree amine. That is what 2 hydrogen is there. Hydrogen bonding is existing, but here there is no hydrogen bonding existing. That is what 3 degree amine having least 1. And next one is a very important one. Ethyl amine is soluble in water and aniline is not. Why? This was frequently asked in the year of 2011, 9, 14. Okay, so aniline as well as ethyl amine. So here the solubility based. Here it has both are having hydrogen bond. Okay, both are having hydrogen bonding. But the thing is here the size of that molecule C2H5, but here the size is very bulk. Moreover, it is a highly hydrophobic one. Aryl group is highly hydrophobic one. That is what which will not be soluble in this case. That is what ethylamine is soluble in water. Moreover, the chain length is very less and the hydrogen bonding is same, but the thing is during that both the thing you just compare it. So here NH2 is common thing, C2H5 is there and C6H5 is there. So the bulky group and moreover the hydrophobic one, that is what it is insoluble in water. And next one is the very important one. This is what the basic strength, what we have to find out the basic strength of the compound given. So how the basic strength will be here. So here the basic strength aniline and para-nitroaniline and toluidine is given. You just look out. So here basic strength, whenever the asking the basic strength, so here aniline having nitrogen having lone pair of electron. Okay. So basic strength is entirely decided by the density of electrons on nitrogen. The maintenance of electron density on nitrogen will give the high basicity. So here you just look out. Here what kind of things are there? Here one donating group is there. So if suppose one withdrawing group is there, so here the common thing is benzene ring, and here one NO2 group is there, one CSA group is there. Here it is highly electron withdrawing, here it is highly donating. So this donating will help us the nitrogen to maintain electron density. The electron density will be maintained because the donation of these electron will give basicity. So the basicity is nothing but the donation of electron. So here the electron cloud should be maintained, that can be maintained by electron donating group. But in this case electron withdrawing group is there, here there is no group is there. Okay, you just look at, so here this is a position number 1 and here there is no withdrawing group is there, that's what this is a position number 2, and here one withdrawing group is there, that's what the position number 3. Are you able to understand? This is a highly basic para-toluidine. You just look at CH3 and NH2 para position. Here para-nitroaniline, NH2 and NO2 is there, and here aniline is there. Are you able to understand? It's very important one. You just look at. And the very important next one is which is more basic. This is also very important. So here as per the same reason. So here one donating group is there. In this case one donating group is there. Here there is no donating group. That is what, which is this one having higher basic strength. This one having lesser basic strength. And here also you just compare it. Here one electron donating group is there because methyl group is electron donating and phenyl group is electron withdrawing. Here this group is electron donating group. But here this phenyl group is electron withdrawing group. So if it withdraw the electron, the nitrogen density will less. Okay, the maintenance of electron cloud on that nitrogen will become less. That's what is less basic. Here the maintenance of electrons on the nitrogen, okay, will be maintained by this methyl group, donating group. That is what it has a high basic strength and this has less basic strength. Are you able to understand, students? It's very, very important one. And next one is, the thing is, complete the following reaction. This question was asked in the year of 2012 All India Board. So here aniline is given and bromine is given. So here aniline, so here you look at aniline is a highly activating group. Okay, highly activating group, that is what I'll be getting this product. What kind of product? So here NH2 is there in all the position, that is here in ortho position and para position as well as ortho position. All the positions are occupied by bromine. So there is no need of bromine water is required because this is a highly electron activating group. That's what it can activate all the positions, ortho and para position. That's what I'll be getting 2,4,6 trinitro-aniline. And why is alkyl amine is more basic than ammonia? So here the same thing, alkyl amine in the sense, say for example, if I am taking a CH3 NH2, this is alkyl amine, okay, and here I am having NH3. So here one electron donating group is there. This is the electron donating group. Which one is electron donating group? Methyl group is electron donating, but here there is no electron donating group is there. There is no electron donating group. That's what once it gives the electron, it will be less basic. Because here the maintenance of electron can be done by methyl group. Methyl group will give the electron and it maintains the electron cloud on nitrogen in NH2. That is what it will be more basic when compared to ammonia. Are you able to understand, students? I think so you understand very well. Thank you so much for watching. Please go forward to others to get benefit and don't forget to subscribe my channel and please give a like to this video. Thank you so much for watching. Thank you. Thank you for learning. Share and like this video.